Good morning, students. This is Latif sir. Today I'll discuss about empirical formula of a compound. Empirical formula of a compound. So, what is empirical formula? I want to explain this term empirical formula by taking one example. You know the formula, chemical formula of glucose is C6H12O6. C6H12O6. This is the chemical formula of glucose. Now, according to this chemical formula of glucose, you can see in glucose 6 carbon atoms. In one molecule of glucose, there are 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atom. Okay. Now, find out the ratio of carbon atom to hydrogen atom to oxygen atom. Number of these atoms. Okay. So, the ratio of carbon atoms to hydrogen atoms and to number of oxygen atoms in case of glucose is 6 is to 12 is to 6. Now the simplest ratio become 1 is to 2 is to 1. Okay. So in the simplest ratio of glucose, you can see 1 carbon atom, 2 hydrogen atoms and 1 oxygen atom are there. So according to the simplest ratio of glucose, the formula of glucose become CH2O. CH2O, but actual molecular formula of glucose is C6H12O6. So the simplest formula of glucose, that is CH2O, which is called empirical formula of glucose. So what is empirical formula? The empirical formula of a compound is the simplest formula. Empirical formula of a compound is the simplest formula which gives the simplest ratio in whole numbers of atoms of different elements present in one molecule of the compound. The empirical formula of a compound is the simplest formula which gives the simplest ratio in whole number of atoms of different element present in one molecule of the compound. For example, empirical formula of hydrogen peroxide is HO, but actual formula of hydrogen peroxide molecule is H2O2. So in H2O2 you can see in the one molecule of hydrogen peroxide, the formula of hydrogen peroxide molecule is H2O2. So the ratio of hydrogen atom to the number of oxygen atom in H2O2 is 2 is to 2. So the simplest ratio is 1 is to 1. So according to the simplest ratio of hydrogen peroxide, you can see 1 hydrogen atom and 1 oxygen atom are present. Okay. So the empirical formula, according to the simplest ratio of hydrogen atom, number of hydrogen atom to the number of oxygen atom in hydrogen peroxide is HO. But the actual formula or actual molecular formula of hydrogen peroxide is H2O2. So empirical formula of hydrogen peroxide, that is H2O2, is HO. Okay, similarly empirical formula of glucose formula is C6H12O6. The empirical formula of glucose is CH2O. After you have to calculate the simplest ratio first. Simplest ratio of number of atoms of different elements. Okay. Now the empirical formula mass. What is empirical formula mass? The empirical formula mass is the sum of atomic masses of various elements present in the empirical formula. The empirical formula mass is the sum of atomic masses of various elements present in the empirical formula. For example, the molecular formula of hydrogen peroxide is H2O2, you know that, but the empirical formula of hydrogen peroxide is HO. So empirical formula mass of hydrogen peroxide, is 1 plus 16, 1 for one hydrogen atom and 16 for oxygen atom. Empirical formula is empirical formula mass you can calculate by adding the atomic masses of different elements present in one empirical formula unit. Okay, so empirical formula mass is the sum of atomic masses of various elements present in the empirical formula. Similarly, you can calculate the empirical formula mass of glucose. You know, empirical formula of glucose is CH2O. So empirical formula mass of glucose, according to the empirical formula of glucose, is for carbon 12, you have atomic mass is 12. For hydrogen atomic mass is 1, and for oxygen is atomic mass is 16. So empirical formula mass of glucose is 12 plus 2 into 1 plus 16. 12 plus 2 into 1 plus 16, that is total is 30. 30 is the empirical formula mass of glucose. Okay. Now determination of empirical formula of a compound, that is how to determine the empirical formula of a compound. The empirical formula can be calculated from the percentage composition of the compound as follows. The empirical formula can be calculated from the percentage composition of the compound as follows. So there are some steps you have to follow to determine the empirical formula of a compound. So first step is the percentage weight of oxygen, carbon, hydrogen, these necessary elements. You have to provide the percentage weight of the elements present in the compound. Okay, so if the percentage composition of any element not given, then you have to subtract the sum of other percentage mass of other elements from 100. Okay, so the percentage mass of each elements present in the compound will be given, and then in the second step the percentage weight of each element is divided by the atomic weight. That is in the second step you have to divide the percentage weight by atomic number of each respective elements. Okay, and this gives the ratio of number of atoms in one molecule of the compound. So in the first step, the percentage weight of each atom, each elements present in the compound will given. So you will provide the percentage of the each respective elements present in one molecule of the compound. Then in the second step you have to divide the percentage weight of each element by their atomic mass or atomic weight. And in the third step, if the molecule contain water of crystallization, then its percentage weight is divided by the molecular weight of water, that is 18. Molecular weight of water is 18, and this gives the ratio of number of water molecules in one molecule of the compound. And in the fourth step, to get whole number ratio of atoms, To get in the, I have told that in the second step you have to calculate the number ratio of number of atoms present in one molecule of the compound by dividing the percentage weight of each element with their respective atomic weight or atomic mass. And after that, to get a whole number ratio of atoms of different elements and water molecules, the numbers obtained in step 2, that is second step, and third step by the smallest number. To get a whole number ratio of atoms of different elements and water molecule, the number obtained in second step and third step are divided by the smallest number. And in the last step, the empirical formula is now derived by writing the symbols of various elements side by side with the number of atoms of each one as the subscript to the lower right of its symbol. In the last step, the empirical formula derived by writing the symbols of various elements side by side with the number of atoms of each one as the subscript to the lower right of its symbol. Okay, now using these steps you can calculate or you can find out the empirical formula of some chemical compounds. See the example 4. In this example, the question is the molecular formula of an organic compound is CH3COOH. Molecular formula of an organic acid is CH3COOH. Now question is, what is the empirical formula? So the molecular formula of the compound, that is CH3COOH, we can also write the same formula like this: C2H4O2. C2H4O2. Now ratio of carbon, hydrogen and oxygen is 2:4:2. So the simplest ratio is 1:2:1. Okay, because I have told that you have to find out the simplest whole number ratio of each respective elements. So the empirical formula of CH3COOH is CH2O. This is also an empirical formula of glucose. Okay, you have to remember that CH2O is also empirical formula of glucose, and it is also empirical formula of CH3COOH. Now see example 5. Find the empirical formula of the compounds with the following percentage compositions. I have told that first in the question, percentage composition of each respective elements will give, and then you have to find out the atomic ratio by dividing the percentage composition with their, you have to find out the atomic ratio by dividing the percentage composition of each respective element present in the molecule by their atomic masses. And then after that you have to find out the simplest whole number ratio. So in example 5 you can see two questions are there. In the first question, zinc see question number 5a, that is in this compound zinc is present 47.8% and chlorine is 52.2%. So the ratio of zinc percentage composition of zinc and chlorine is, so you have to make a table and you have to make total 5 column. In the first column you can see the name of elements and symbol of elements given, that is zinc and chlorine, and percentage of zinc is 47.8 and percentage of chlorine is 52.2. Total percentage will be 100%. Okay, and atomic mass of zinc is 65, atomic mass of chlorine is 35.5. Now you have to find out atomic ratio. So atomic ratio of zinc is equal to atomic ratio of zinc is equal to the percentage mass or percentage composition of zinc divided by atomic mass of zinc, that is 65. So atomic ratio of zinc is 47.8 divided by 65, that is 0.73%. And atomic ratio of chlorine is 52.2%. Now we have to divide the 52.2% with 52.2 with by atomic mass of chlorine, that is 35.5. So after dividing the after dividing the percentage composition of chlorine with or by atomic mass of chlorine, that is 52.2 divided by 35.5, the atomic ratio become 1.46. And I have told that now you have to find out the simplest ratio of atomic ratio. Okay, so atomic ratio of zinc is 0.73 and atomic ratio of chlorine atom is 1.46. Now we have to further simplify the ratio. Okay, and you have to find out the simplest ratio, you have to divide all the you have to divide the atomic masses or atomic ratio of all elements by the smallest atomic ratio. Okay, so atomic ratio of zinc is 0.73 and atomic ratio of chlorine is 1.46. Now we have to divide the atomic ratio of both zinc and chlorine by 0.73. Okay, so the simplest ratio becomes zinc 1 and chlorine 2. So in the compound of zinc and chlorine, the ratio of zinc atom and chlorine atom is 1:2. So empirical formula of the compound of zinc and chlorine is ZnCl2. And next part of this question 5b, see magnesium 9.46, sulfur 13.01, oxygen 26.01% and water 51.22%. Now again you have to make a table according to question B. Magnesium 9.76%, sulfur 13.01%, oxygen 26.01% and water 51.22%. Okay, so first write down the symbol of elements and it is written in the table. You can see magnesium, sulfur, oxygen and water. Now you have in the second column you have to write down the percentage composition of each respective elements. Okay, after that in the next column you have to write atomic or molecular mass of each respective element. So atomic or molecular mass of magnesium is 24, atomic or molecular mass of sulfur is 32, and atomic mass of oxygen is 16, and atomic molecular mass of water is 18. Okay, now to find out the ratio of atoms or molecules, you have to divide the percentage composition by their atomic masses. So for magnesium, ratio of atoms is 9.76 divided by 24, that is 0.406. And now calculate percentage ratio of atoms of sulfur. Sulfur percent composition is 13.01 and atomic mass of sulfur is 32. So divide 13.01 by 32, you will get 0.406 also. Okay. And in case of oxygen, percentage composition of oxygen is 26.01 and atomic mass of oxygen is 16. So to find out the ratio of atoms of oxygen is, you have to divide the percentage composition by atomic mass of oxygen. So 26.01 divided by 16, that is 1.625. And in the last elements or compound is water, and a percentage of water given that 51.22%. And you know molecular weight or molecular mass of water is 18. So atomic ratio of molecule of water in this compound is 51.22 divided by 18, that is 2.86. Now you have to calculate the simplest ratio by dividing the number of, or by dividing the ratio of atoms or molecules with the simplest or by the simplest ratio of atoms. Okay. So simplest ratio of magnesium is 0.046 divided by 0.046, and simplest ratio of sulfur is 0.046 divided by 0.046, that is also 1. And simplest ratio of oxygen 26.01% and atomic mass of oxygen is 16. Now the ratio of atoms of oxygen is 1.625, it is calculated. And now you have to find out the simplest ratio of oxygen in the atom in the now you have to find out the simplest ratio of oxygen atom present in the molecule or present in the compound. Okay. So simplest ratio of oxygen is 1.625 divided by 0.046, that is 4. Simplest ratio of oxygen is 4, and simplest ratio of water is 51.22 divided by 18, that is 2.84, and you have to divide this 2.84 by 0.406, and the simplest ratio for water becomes 7. 2.884 divided by 0.406. So the empirical formula of the compound of magnesium, sulfur, oxygen and water is 1 magnesium atom, 1 sulfur atom, 4 oxygen atom and 7 water molecules. So MgSO4.7H2. This is the empirical formula of the compound. Now see example 6. In this example, it is given that an organic compound has oxygen 26.24%, oxygen 26.24% and hydrogen 4.92%, and it is told that the compound is organic compound. So carbon is also present. So first you have to find out the percentage of carbon. It is not given here, so you have to find out by subtracting the sum of percentage of oxygen and hydrogen from 100. Okay. So percentage of carbon in this organic compound is 100 minus within first bracket 26.24 plus 4.92, that is percentage of carbon becomes 68.84. So in the box or in the table, first you have to write down the symbol of elements, that is carbon, hydrogen and oxygen present in this compound. You know that percentage of carbon is 68.84, percentage of hydrogen is 4.92, percentage of oxygen is 26.24. And you now in the next column you have to write down the atomic mass of each elements. Atomic mass of carbon is 12, atomic mass of hydrogen is 1, atomic mass of oxygen is 16. So in the next column you have to find out the atomic ratio by dividing the percentage composition with by their atomic mass. So atomic ratio that is number of atoms in one molecule, or it is also called atomic ratio of carbon, becomes 68.84 divided by 12, that is 5.74. And atomic ratio of hydrogen is 4.92 divided by 1, that is 4.92. And in case of oxygen, atomic ratio is 56.24 divided by 16. Okay, that is 1.64. Now you have to find out the simplest ratio by dividing the atomic ratio by the smallest number. Okay, so simplest ratio of carbon is 5.74 divided by the smallest number here is 1.64. So 5.74 divided by 1.64, that is 3.5. It is the simplest ratio of carbon. And for hydrogen, simplest ratio is 4.92 divided by 1.64, that is 3. And percentage composition of oxygen is 1.64 divided by 1.64, that is 1. Okay, so in this case you can see the simplest ratio of carbon becomes 3.5, and simplest ratio of hydrogen in this compound is 3, and simplest ratio of oxygen is 1. Now you have to multiply all these three simplest ratio, okay, by 2 in order to change them in whole number. That's why you have to multiply all the simplest ratio by 2. Okay, and after multiplying, the ratio of carbon is to hydrogen and oxygen becomes 7 is to 6 is to 2. 7 is to 6 is to 2. And this is the empirical formula of the compound, that is C7H6O2. C7H6 and O2. Okay. Next day I will discuss about how to calculate molecular formula. Okay.